On this DeBacco University video, we're going to look at phase change relation to heating and cooling curves. Yes, we might be using water as an example, but this does apply to other things, but hopefully this will allow it to be relatable and also understandable through the explanation process. All right, so as I said, we're going to use water as the example because it's easy to understand since it's easy recognizable, but this concept applies to more than just water. And the question we want to ask, what causes water to go from one phase to another? Again, it applies to other things, but we're probably more familiar with the ice, the gaseous form, and the liquid form of water, the evaporation, the freezing, the deposition, the sublimation, the melting, all of those key terms as water is going from one phase to another. So energy results in a phase change. So adding energy is going to be an endothermic change since molecules will move further away. This occurs when the ice is melting, the water is boiling, or we're going through the sublimation process. If we're removing heat from that process, that would be an exothermic change, and those molecules as a result are going to move closer together. That's going to be freezing, condensation, or deposition. Now those phase changes, looking at our little typical phase change diagram here, when heat's added, again, solid to liquid is going to be melting. We're going this way. Then we're in that liquid phase, and we're going to have vaporization, and then we could have going from a solid directly to a gas would be an example of sublimation. Sometimes that occurs with snow that actually falls, and then the sun comes out, gets really bright, and go right to the gaseous phase, skipping the liquid intermediate phase. Now when heat's being absorbed, this is where we're having freezing occurring. So we're going this way. We're going basically from a liquid to a solid. Or we're going from a gas to a liquid. We're having that condensation. Could also have a deposition, which is a gas directly to a solid, again, skipping that liquid phase. So heating and cooling curves specific to water. Now we can bring in temperature, and we could see how the molecules are moving different. In the solid, they're kind of closer together, vibrating in place. The solid to liquid phase, they're starting to break apart. The liquid phase, they're sliding across one another. The gas to liquid, they're again take more energy, getting more disorganized. The gaseous phase, they're at their highest energy state in this example. Again, we see energy or heat added, and we see temperature here in degrees Celsius as a comparison. Lastly, looking at phase change can be also impacted by pressure, so I don't want to forget that it's not just only temperature. Pressure can also be an influence. The water triple point in a specific temperature and pressure is where the solid, liquid, water, and gaseous water vapor can coexist in a stable equilibrium. So when we're having that solid, that liquid and that gas phase, that triple point is right here. This is looking at pressure. So again, if we're massively increasing or decreasing our pressure, that can affect the temperature at which water will be in the solid, the liquid, or the gaseous phase. So I just want you to keep that in mind, that we're typically thinking of all these things occurring at sea level, or essentially one atmosphere. So that's typically what we're used to, is this horizontal red line here. But again, you can see if we're changing our pressure, that can change also or alter the temperature at which water boils at, which water freezes at, and all other aspects. So don't forget about that. We'll kind of think things that typically at one atmosphere, but realize that in science we can do other things that can have an impact, so we need to sometimes take those into consideration.